Hi friends, today we're going to talk about exponential growth and decay, and we're going to be writing equations to represent word problems or real world situations. The numbers that we're going to be using today to fill in, we're going to be filling in the initial amount, so just how much money or how many whatever they start with. We're going to be finding our rate, so it's either rate of increase or rate of decrease. It's important to know to find the rate. We have to do whatever percentage they give us and divide it by 100. Those are the two main things we're going to fill in, and then we're also going to fill in whether it's adding or subtracting. If it's growing or getting bigger, we're going to be doing 1 plus our rate. And if it's getting smaller, we're going to be doing 1 minus our rate. All of our equations that we're writing today is going to have this A of t, which would just give us our final amount, and the t. So again, we're just filling in for the A and the R, the little a and the R. The town of Oakville has a current population of 5,000 people. So that's the initial value, 5,000 people. The town's planning committee predicts the population will grow. So I know I'm going to be doing 1 plus my rate at a rate of 3% each year. So our growth factor, we have to take our percentage, which is 3, and divide by 100, which is 0.03. We said it was growing, so we're going to be doing 1 plus. So our equation, as I said, we're going to start with A of t on all of these, equals our initial value, which is 5,000. It's growing, so we have to do 1 plus 0.03. to the power of t, but then we're going to simplify this. 1 plus 0.03 is 1.03, so our final answer then, A of t equals 5,000 times 1.03 to the power of t. Let's look at another one. A biologist starts a culture with 100 bacteria, so that's our initial value. 100. This specific type of bacteria is known to increase by 100%. So again, since it's increasing, it's going to be growth. And if we do 100 divided by 100, that's 1. Again, we're doing our percentage divided by 100. So our equation, A of t equals our starting value times 1 plus 1 to the power of t. 1 plus 1 is 2. So our final answer then will be A of t equals 100 times 2 to the power of t. A scientist has a 200-gram sample of radioactive isotope. So that's the initial value, 200. The substance is unstable and decreases. Since it's decreasing, it's going to be decaying. It's mass by 50% every hour. So to find our decay factor here, I'm going to do 50, which is my percentage, divided by 100, which is 0.5. And now when I write this equation, A of t, so to find out how many grams are left after a certain amount of time. Our initial value is 200. It's decreasing, so 1 minus 0.5 to the power of t. And then simplifying, 1 minus 0.5 is 0.5. So A of t is 200 times 0.5 to the power of t. One more. A patient is given 500 milligrams of a pain reliever. The body metabolizes the medicine, so the amount in the bloodstream decreases by 15% every hour. So it starts with 500. It's decreasing, which means it's decaying. To find our decay factor, we'll do our percentage divided by 100, which is 0.15. So my equation then, A of t equals 500 times 1 minus 0.15 to the power of t. If we did 1 minus 0.15 and simplify that, I get 500 times 0.85 to the power of t. All right, friends, that's it. Have a nice day.